Hello and welcome back to the Land and Climate podcast. My name is Alasdair, and this week I spoke to Inge Schrijver about her recent research into how wellbeing was incorporated into climate change modelling and into the current state of climate modelling for policymaking. Inge is a PhD researcher at the Institute of Environmental Sciences of Leiden University in the Netherlands, and together with colleagues at the end of last year, she published a new paper which explores the extent to which wellbeing has been considered in climate models.
Climate change is very practical, very much here and important for your life. It's not 2 degrees of warming. No, it's like, can I have my food still? Is my house going to be flooded?
I started by asking Inge to explain her most recent research and set out what exactly the term well-being included.
So the way these models work is that you have scenarios of, for instance, economic growth, population, and those kind of factors, and then how that affects climate change, or how different ways of production result in climate change. But they don't usually look at how that climate change then actually can impact that production again, or impacts humans again. So that was the starting point of this research, to see climate change is actually one of the biggest threats to our lives, but a lot of models don't include actually human impacts. So that's what we try to look at. And for well-being, it's quite a broad term that has a lot of different backgrounds. And so we come at it from the angle of wanting to go beyond GDP. So looking beyond income production in models and model well-being, which is much more important to people's lives. But there's other traditions to look at well-being. So you could be a psychologist or a sociologist looking at what's important for well-being. And so for this research, I took quite a pragmatic approach, and I took a review of a colleague who has looked at all these different kinds of well-being approaches and looked at which elements are mentioned in all these different works. And then you get to things like income, food availability, health is a very important one, education, cultural activities, but also inequalities. So you can look at general well-being in a population, but there's always certain groups that have more or less, or are better off or worse off. There can be difference between countries, etc. So also those kind of inequalities are important. But also the environment you live in. Do you have a park nearby that you can enjoy or not? So there's a lot of different elements in that sense that are just important to people's lives. Basically, we took a very simple approach. We listed 10 that were mentioned a lot, and then looked for climate literature on how does climate impact those elements.
And your overall conclusion is that they're missing from the majority of modelling.
So actually a lot is known in the scientific literature, both qualitatively but also quantitatively, about impacts of climate change. So for instance, there are studies that look at suicide rates. So if temperatures rise, there are more suicides, or there's more conflicts. There can be, of course, water shortage, but also all sorts of diseases like heart disease or heat stroke. So actually, when I started looking at it, I was surprised by the amount of information that was actually available. And I was surprised about it because I started from this point where a lot of models don't include these impacts. I thought not much was available. But scientifically, we know quite a lot about climate change impacts. It's all studies from one specific field. So in health, there's knowledge about health impacts. But these models that I looked at, these integrated models, they're much broader, of course. And they didn't include much. So one of the conclusions is that we know a lot about climate impacts, but a lot of these broader models don't include them. But that means there's a lot of potential to do so in the future.
Can we just explain for listeners, and because many listeners might not actually understand the models themselves, how they work, and in what circumstances they're actually used?
I looked at 3 different types of models. One class is integrated assessment models, and then you have 2 different types. One is a cost-benefit model, where they look at how much does it cost to prevent climate change and how much does climate change itself cost. Then you find some optimal points of paying to prevent climate damages. These are called cost-benefit integrated assessment models, and they can, for instance, be used to determine carbon prices. And also in the past of what is an optimal level of warming. Unfortunately, there's a lot of assumptions that go into these models that you can have a lot of critiques on. Previously, the optimal level of warming was considered, for instance, to be 4 degrees, which from climate science perspective, it really makes no sense because we know it will be bad. So in no way a 4-degree world is an optimal world. That's because of the assumptions that go into these models. That's one of them, the cost-benefit ones. And then the second one is process-based IAMs, which are much more detailed. So they model the energy system or the agricultural activities. They take these external scenarios on social and economic development. And so how will the economy develop in terms of GDP, education investments, inequalities between countries, etc. There's 5 different scenarios. And then they use that as an input to their model. And then they model how much energy do we use? Where does the energy come from? Is it from renewables or oil, etc.? And then they calculate climate change, so degrees of warming. So this can either be used to say, okay, we want to limit warming to 2 degrees. What kind of policies do we need? How many renewables? Or it can be the other way around. We have a policy. How much warming does that lead to? So those are more the integrated assessment models. And then there's a third one, this system dynamics, which is much more about interactions. And they usually include more different systems and how do they interact with each other. The limits to growth model was a system dynamics model, and there's currently quite some new ones that are being developed, but they're much less influential than the other types. And for all 3 accounts that they don't really have many of these environmental impacts to well-being.
Can we just explain a little bit more about the specific organizations that are actually using each model, but just so that listeners can get a picture of how it could be influencing policymaking itself?
The most prominent use of these models is for the IPCC reports. And you have a lot of different IAMs that calculate these different scenarios. So it's used in the IPCC reporting to report on which policy measures are needed to stay within certain limits and what are the possibilities, basically, that we can stay within a certain amount of global warming, how many renewables are needed, do you need negative emissions or not, all these kinds of calculations. Also, national governments use specific models for their own policies. I know a little less about that. I know, for instance, with the system dynamics models, there's a few that are specifically made for certain countries, which is quite interesting, but they're more tailored to a specific government's need rather than a general model that can be used by anyone.
What do you think is going on here? Why is well-being being missed out?
The purpose has been to calculate global warming and policies for global warming, and not necessarily what are the human implications of that. These socioeconomic scenarios are called shared socioeconomic pathways, and it's useful to have a set of scenarios that are the same for different models because it's easier to compare. But then the problem is that these factors are external to the model. So the model itself cannot say anything about it, whereas a lot of the human impacts are exactly in that sphere. It is about population, because population contains how many people are there. That also means how many people die and why do they die? How long do they live? Do they have diseases or not? So all these kind of dynamics are not in it. Also, I think because in the social science sphere, there's less of a tradition of doing this kind of quantitative modeling. It's also more difficult to then to develop these models because you do need to have the quantitative relationships available. And I think recently this is something that has been coming up more, which is very important. But because the main focus has always been on more the economic side, so really being able to calculate GDP or purchasing power kind of stuff, rather than how are people doing? I think a shift in focus needs to happen, not only in climate modeling, but in economic modeling as well.
To what extent would there be a willingness to start including a wider range of factors in modeling?
With certain groups, I think there is quite a willingness. I think for the IAM community itself, there are people who are engaging with this topic. And I must also say it is also complicated, right? Because incorporating climate impacts means that you add things to your model. And most of these models are already really big. It takes days to run. So if you make your model and you want to calculate something, you hit go, it might take you a week to get the results. So if you then make your model more complicated by adding more factors, it might take you a month to run the model. So there is also a trade-off and how much a computer can do. Although, for instance, one of the models that I studied is an extension of one of the IAMs, the image model, where they use the image outputs and then they calculate human development damages. So you could try to add different models together to calculate these damages. But system dynamics models are more suited to these kind of questions because they include different domains, including a lot of social factors, and they close everything in the model and look at the relationships between them. But usually they are less detailed. So for instance, with IAMs, they also have different level of details, but you can have specific sectors like the energy sector or different regions, and you can be very specific, calculating or modeling all the countries in the world, or splitting into Europe or sub-regions of Western Europe, Eastern Europe. So you can be more or less specific and detailed, both in terms of country or regions that you cover or sectors that you cover. A lot of these IAMs can be quite detailed, but they don't have a lot of interactions, whereas the system dynamics models have much more interactions but less details. So both would have to move a little bit towards each other, but that also just costs time. There's definitely interest within our project. Also, we're more in the post-growth sphere, so people who want to model beyond GDP and model beyond economic growth are starting to develop their own models from a different starting point. You don't have to adapt your whole model to be able to do this, but you do it from the start. But there's definitely interest from these communities to include it. Modeling these environmental impacts remains something that a lot of people find difficult to do.
That's kind of crazy though, isn't it? That the development of these models has become so specifically about emissions and climate itself and missed out a whole range of massively important factors.
I think climate change becomes a very abstract and technical thing. And of course, with models, they're also quite abstract and technical. So you get into that, whereas actually climate change is very practical, very much here and important for your life. You know, it's not 2 degrees of warming. No, it's like, can I have my food still? Is my house going to be flooded? Think more in terms of well-being. I think climate change also becomes more relevant to people's lives. But with models, maybe also necessarily becomes a bit more technical and abstract.
Which is why I was going to ask you about, you refer to IAM community. Can you say who this IAM community is? Because also there's a system dynamics one, but it'd be interesting for listeners to get an idea of who are we talking about here.
It's scientists among each other trying to develop their models. And there's a lot of groups that come together around topics. There's one on the bigger IAMs that are really used for the IPCC, but any other group that wants to get involved, they organize conferences, knowledge sessions, things like this. That's something I'm not really part of. So for instance, there's also the post-growth community with groups that are really coming from post-growth economic modeling, where climate is one of the elements, or an argument of why we should go beyond measuring just GDP. There's also conferences, the Society for Ecological Economics and Degrowth conferences. People meet to form these kind of communities. For post-growth, there's this relatively new development, new community. So on one of these conferences, people got together on the modeling side as well, because of course the idea already exists for longer, but the idea to try to model this and quantify and be able to calculate different policies. A few years ago at a conference, people got together and self-organized into these groups. We had a post-growth narrative workshop last year to see, could we come up with something that replaces those shared socioeconomic pathways that are exogenous, but still come up with some sort of narratives that are coherent, that different models could actually model and compare. So those are partly those two, so that let's say the IAM community and the post-growth community are different ones, but they also overlap because there's people who come from the IAM world and are also in this post-growth groups.
One of the things I was guessing at when you were saying this was that, is there any tribalism or factionalism? You come out with some research and you might be seen to be from the post-growth community. And so your research may be not as highly regarded by those who are already working in the IAM community.
I'm not sure exactly, but it is definitely the case that, especially with these larger IAMs, they're huge models. You either know how to use the model or you do not. Once you're using that model, you usually keep using it because that's what you've learned and what you've invested in, which makes sense also from an institutional perspective. So there are specific universities or specific institutions that have that model and develop that model. So then you also keep developing in that line.
And some people would argue that some of the IAMs have created mistakes.
I guess with the assumptions, it also really depends if you have the cost-benefit analysis or this more process-based analysis, especially with the cost-benefit ones, with like the 4 degrees of optimal warming. Those conclusions really depend on assumptions. For instance, there's assumptions on that basically 90% of GDP is unaffected because work happens indoors. So then they model that agricultural sectors are impacted heavily from climate change, but people who work indoors are also affected by climate change. So you cannot just say it's not affected. You can assume that. But if then your conclusion is there's only a 3% GDP damage at 3 degrees of warming, then that's not actually your conclusion. It's your assumption. And for the process-based ones, carbon capture and storage things, all the scenarios include economic growth. And if you need to grow, then at some point you also need to have negative emissions because we're emitting too much. That's why this post-growth community is trying to see, can we come up with a no-growth scenario and see what happens, or a negative growth scenario and see what happens. But that's also difficult because all the assumptions in normal economic models don't allow you to do that. So that requires a lot of development. But yeah, so if you assume climate change has a certain negative impact or certain costs to mitigate the impact, then you might say, okay, it's too costly now to reduce our emissions. So instead, in the future, we're going to take CO2 out of the air because that's going to be cheaper. But all of that is also based on assumptions and based on the fact that in such a scenario, you might surpass 1.5 degrees, but by taking carbon out of the atmosphere later, you go back to 1.5 degrees. But we don't even know if that's possible, because maybe after you've passed 1.5 degrees, it only gets worse. You might trigger processes that will just reinforce the heating, and removing some carbon later might not make any difference anymore.
Your research mentions inequality as well, and it's also one of those factors in well-being. Can you say a little bit more about that aspect and maybe why it seems to be largely ignored in a lot of climate modeling?
Yeah, for us, inequality is really an important part, because with climate change, on the one hand, there's a huge inequality in who causes climate change. And usually those places that are impacted most are also with those people that didn't cause it. And then another one is adaptation. And that's something that's also usually not included in these models. But some people are better able to adapt to it or not. And a lot depends on money. So if it gets hot, are you able to buy an air conditioner, for instance, which then also uses more energy again. So you start having some loops. But yeah, are you able to adapt? Maybe you need new machinery or a different method of working compared to what you're used to. These are very important dynamics. So if you look at just average impacts, it doesn't really tell you which groups are impacted most or least. So it's something that's really important to include. But that's also difficult because then you actually have to know these things and have to have the data in your model, which means that it becomes more detailed and therefore more difficult in terms of computational power. It costs more time again to run your model. You need to know more of these relationships. So you cannot just say, okay, 1 degree of warming causes 2% increased suicide rate, for instance. But then you would have to know, okay, which groups are most at risk? And does my model even include these groups? So then it becomes more complicated, but it is a really important factor. And you can, of course, start in a simple way and perhaps just have 5 income groups, so income quintiles, and say, okay, the top income group has this much impact, or the lower this one, or men versus women, or elderly versus working population versus children. Those are usually things that are available in data.
Could you say something about the technological assumptions or favouring of technology which exists in the modelling as well? And actually, the lack, it seems to have any consideration of issues like actually just reducing demand.
The way these models work is they model generally production. So how energy is produced, how agricultural products are produced. Last IPCC report, there is a whole chapter on demand and demand reductions. There's a very interesting blog post by a Parik degrowth scholar who actually finds a lot of degrowth arguments and lines of thinking in the IPCC report. It's just not called like that. But they have shifted attention to also these demand measures and the importance of decreasing demand, changing, shifting demand. So it is something that has gotten attention in the IPCC report, although a lot of people don't realize it, but it's not so much in the models yet. Demand reduction really is an important, or a change in demand, like I said, with diets. You still need to eat the same amount of food, but if you eat a different food, it can have a very large impact. More than in a meat-based diet, you could change what the cow eats or how many animals you can keep or those kind of things. And you can change emissions. But if you just don't eat the animal in the first place, it's much more effective.
Policymaking itself might not be including enough of these additional factors. And it's often narrowly focused on either economic outputs and outcomes or very specific climate outcomes and outputs.
Yeah, I think that's true. I worked for a Dutch ministry for a couple of years as well, also trying to look more at what we call it broad prosperity, but also this broader idea of economic development, so to say. And I think there is a maybe odd paradox that most people who are working in government do not think they are working on increasing GDP. That's their goal. There's a lot of different policy goals, of course, and that's also true. There's lots of social policy, lots of climate policy. But in the general narrative, also within the government, a lot depends on, are things economically viable? Are they going to cost us money? We actually in the Netherlands have had a big cut in education budgets, which now has been reversed, because you can also think of education as an investment, right? So we invest in education so that in the future our economy will be better, which is still an economic argument. You could also just say we want to invest in education because we want to develop people and for people to have a nice life. You want them to be educated. But the economic argumentation and narrative is very dominant, which is true. And there is, I think, a whole ecosystem that keeps that in place, because it's also journalists that are very keen on reporting GDP figures. So if every quarter the Statistical Bureau publishes the GDP growth figures, there will be an article about it in a newspaper. Whereas with some other figures, maybe there's less interest. So there's not one party that's to blame, but everyone influences everyone to do that. That's for us also one of the reasons why we want to work on well-being, and we call sustainable inclusive well-being, to replace GDP as a focus. Part of that is in the narrative, trying to talk about well-being as something that's important. Part of it is about the technical part of, okay, then how do we calculate well-being? Because also with GDP, it's just a number, but there's actually a whole system underlying that basically counts everything that happens in the economy. And in the end, we call it GDP. But you could do something similar with sustainable inclusive well-being. You could count people. You can count healthy years that people have lived, etc. So you can create a similar line of thinking for sustainability, inclusive and well-being, so that you can also be more consistent in how you report about well-being. That's also something we're trying to do because it's a much broader topic. There's also a lot of different approaches, a lot of different terms, etc., which we're trying to bring together and harmonize, just like what was done with GDP. Because there were different approaches of measuring GDP. At the UN, the statisticians came together and decided, okay, this is how we're going to do it. We need something similar for well-being, and say, okay, there's 100 different approaches, but this is how we're going to talk about it now. And we're going to call it sustainable inclusive well-being and keep repeating the term so that it becomes a narrative in policymaking, but also in general life, I would say.
My thanks to Inge Schrijver for her time. As usual, we have a further reading list selected by Inge on the issue that you can find on our podcast blurb or on our Land and Climate Review website. We also have a back catalogue of previous interviews with experts on climate modelling, which you can also find amongst our podcast episode list. And we've also got a link also on our blurb. And that includes our conversation with Wim Carton a few years back, which is, at least I think, interesting and still relevant. Thanks to Vasco Kostovski for audio engineering the show, and please don't forget to review and follow the show if you like it, and we'll be back again in a fortnight with another interview. My name is Alasdair, and thanks for listening.